Welcome back. Welcome back to day 4 of the Smart Manufacturing Experience at IMTS. I'm Dave O'Neill. I'm the Vice President of the Media Group at SME, and we've been having a great week with these presentations. Half-hour presentations in the Smart Manufacturing Experience. They run about 25 minutes, and then I'll be in the audience to do a 5-minute Q&A. So welcome this morning. He did me a favor and said he could just be known as KD instead of his full name, Chief Technology Officer at FactoryEye. So please welcome KD to the stage.
Hey, thank you. Okay. There you go. Now it's working. So, my name is so complicated that I'm like, if Kevin Durant can be KD, so can I. So let's keep it that way, right? My name is KD, and I work with FactoryEye. And look, I mean, oh, there it is. It is working. I talk to a lot of our mid-sized manufacturers, who are our customers and who are our prospects. And one thing we hear a lot is some of these, right? I don't know whether you connect yourself with some of these, but one thing for sure that they have a lot of data silos. They usually have ERP systems, whether that's JD Edwards or SAP or Infor or something else. They have quite sophisticated machines. They're collecting a lot of data through sensors and whatnot. They usually have a quality control software where they keep all the quality data and so on. But then you ask a simple question that how efficiently you are running. Are you on track with your job? They're like, no, I have no idea. Okay, and so that data silo is still a huge problem. And our company owned a tool called XPI, which did integration. And all it will do is move data from ERP to MES back to ERP to your QC and so on. And we started looking at it. We are like, it doesn't make sense to deal with data that way. How about we bring all the data in one place and then look at it, run the analytics on it in a structured way instead of trying to pull data from here, put it in a spreadsheet over here, and then trying to build the graphs. So that's where we started looking at what are the possibilities 4 or 5 years back. So too much data, what do I do with it? How do I bring it in one place so that we can use it in a meaningful way? So while looking at it, we came up with this architecture and that we are very proud of, that data lake for mid-sized manufacturer. And what it means is that, look, at the bottom of it, you have all these systems that's producing data for you, right? Your ERP system, different databases, your Access databases and whatnot. And you also have some of the OT systems like MES. And speaking of digital forms, one thing we see all the time, like so much of paperwork that happens at a factory floor. Instead of taking records in a tablet or computer, there's so much of paper. People are taking notes that at this time I did this. And I'm like, why, right? So now the challenge was, of course, that what do you do with so much of data? How do you store it so that you make the data meaningful? And as usual, when we started, we are like, yeah, let's just put it in a SQL database, right? I mean, it's easy. SQL database works pretty well. But then, over a couple of months at a customer, to be honest with you, they have sensor data coming in every 30 seconds from, over 1,000 sensors. SQL database was like, no, it's not going to work, okay? And so we moved away from SQL database into what we call as a time series database, which is tuned for data like sensor data. Like, you can put sensor data coming in every second if you want to and do it. But then the challenge is that, good, okay, so you got the data into time series database, but what about the current factory state? Because if you want to know whether this machine is up or down, if you have to go to a database to get it, it's too slow. So we said, okay, so for that, we probably need an in-memory database, okay, which is absolutely super fast. You can get the data from there and show it in a dashboard if you want to, that how it works. So in that process of learning, we said, okay, we are going to build a data lake which will be cloud native, You don't have to deal with any of those. In the left-hand side of the database, or the data lake, I should say, is the raw data. And I do have a couple of slides that talks about it. And then from the raw data, you bring pretty much everything you have. Then you have the central processing engine that processes the data and puts it into the actionable side of the database, from where you can take some, bring some insights that when this machine going to fail, or is the machine up or running? Are you out of certain tolerance, and so on and so forth. Okay, so that's how this started. So let me now do a drill down on each one of them and see that how it works. So what the raw data does, that if you look at it from the customer side, from different data sources, it brings the data and put it on the raw data side. Okay. Why this is interesting? There are a couple of things. One, we put an edge component inside customer's network that reads data from ERP and QC and your historian or OPC servers and all those things. So that allows you to read data from the customer network and push it into our raw side of the database. Okay? And it goes to a document data store. I mean, it's a common question I get, why you call it a data lake instead of a database or a data warehouse and things like that. The main difference is that data warehouse is schema in. So when you're reading the data, you are structuring the data. Whereas in the data lake, send us whatever you have. Whatever format you have. You have 10 attributes, 20 attributes. I may use 3 of those, but I'm going to keep everything in the data lake. Okay? And then when you read that data, when you process the data and put it on the right-hand side, which we call as the actionable side of the data lake, that's where you have the schema. So it's schema out for data lake, whereas in data warehouse, it is schema in. And the advantage of that is, of course, like, you need a report. You say, okay, I need this report, and you design a data warehouse. Works great. All you know that your VP then says, can you add this column? And you are like, okay, so now I have to go back and redesign my whole data warehouse to deal with it, okay? But the data lake, it's simple because I already have the data with me in the data lake, the raw side. All I have to do is process the data and move it into the actionable side, and you have a new report, really fast, okay? So going back here, so the raw data coming in from different data sources, all we do is receive that data, put it in our raw side of the data lake so that you lose nothing, and then put it into different buckets for processing. So for example, if it's a ERP data, you are getting the order information in and putting it into the MES system, so you receive the data and make it ready for processing. Okay, so now, once you have that, so these are some of the attributes you need to really think about when you are talking about raw side of the data lake. Is that, hey, you are supporting sensor speed data coming into your data lake, so you have to support that. And, our solution has that, of course. And then you also have to have quality of service, which is, there are certain sensor data is more important than the other. For example, if the machine is running or not, if the temperature is high or not, you need to raise alarms. So those data needs to be processed faster than, let's say, the historical data coming in. So, you have to have the quality of service in there as well. And a lot of the design, that's something we feel proud about, is all metadata driven. So you don't have to go and write a lot of code to create the data structure and so on and so forth. You simply send it to our API, it understands your data structure and puts it in the document store. Okay? So then let's talk a little bit about the data processing. And what it does is, this is a very classic sensor data coming in, right? You have a timestamp with the date and time. You have a tag, and you have a value associated with the tag. And this one has a belt line speed, okay? So that's the raw data you get. But of course, to build meaningful reports and whatnot, you need to what we call as kind of enhance the data and add lot of attributes to it. So if you look on the right-hand side, as you can see, by looking at the old tag name, we translated that to a more meaningful tag name or standardized tag name. Then we parsed the tag to understand what is the location of that particular tag. So it's at a factory in Wilmington. And we also added what product code it is running at that given point of time, whether the machine was running or not. So those are the machine running one. And so the basic point is that you got something and you enriched the data using information from other sources and make it more meaningful. That's one example. The other example is that I'm dealing with it right now is what we call as downsampling of data. What that means is sensor data, let's say, coming in every seconds. You are interested in looking at that maybe for a day or two to understand if an equipment is broken and when an error happened, exactly what happened. But once that data is a week old, you don't care about a second granularity data, right? So you downsample that into maybe a minute. And beyond a quarter, maybe you just keep hourly data. And so that thing is called downsampling. And we do that in our platform. And if you're building yourself something like this, keep that in mind. And then the third thing we also do is that when you have multiple systems, your MES system, which also runs job, you have your JDE system or ERP, that also has the notion of jobs. How do you synchronize the two? Okay, so we have that in our processing engine as well. So just to recap, one is that we enhance the data from something basic to something more meaningful where you can do traceability on this, that, hey, when I was running this particular product, tell me what were the values associated with the product, right? So that's one type, enhancing the data, enriching the data, contextualizing the data. The second one, as I said, is downsampling. And then the third one is like synchronizing two systems, making sure that they are in sync. And then what happens is, let's see, we can go to the next slide. Actually, let me talk a little bit about this. So look, when you are doing processing, the challenge, of course, is how fast and how fast you do it. And it's very common that in big factories, when the data is coming, the sensor data coming in at a high speed, you start getting backed up. And scalability becomes very important. I mean, the way our processing engine is designed, it auto-detect that, hey, there is a slowdown, the queue is building, and it provisions a new hardware in the back end. You don't have to worry about any of that. It gets provisioned in the cloud, and we put our additional engine on top of that so that the queue is always minimal and up to date. And of course, the quality of service guarantees the critical data is processed ahead of other things. Okay? So that's some of the attributes that you need to really think about when you are designing the data structure and the processing engine. Okay? So the final piece, of course, is actionable. And I briefly talked about it, that look, when we started, we thought everything will go into a SQL database, and quickly realized that no, SQL is not going to fit the bill. And as a matter of fact, depending on the different types of data, you need different types of databases. So if it is a sensor data, goes to time series database. If it is a more static product definition or bill of material or raw material definition, that can go into a SQL database. If you are maintaining the latest state of your factory, whether a machine is up and running, what is the temperature of the sensor, or what's the pressure before an extruder, or things of that nature, you need a super speed database from where you can very quickly get that data and process it and use it. For that, we use an InMemory Database for that. And then, of course, we also use a blob storage for things like your recipes, right? Your PDF document or an image or a photo of something, what the operator will see while setting up the machine. So we have all of that in our actionable side of the data lake. And the good news is that once you go past that, so once the data is now structured and actionable, so we started in a completely unstructured side of the database, data lake, where all the data is coming in. We then put it in the right queue, we process it, we put it in the actionable side of the data lake, sky's the limit, right? So now you are going to consume the data on the other side. So now if you look at this one, so now you're on the other side of the data lake, the actionable side of the data lake, right? You can consume the data to update your ERP back. One of the scenarios we hear quite often that, hey, the sales team wants to know, where is this work order? Are we 80% done, 70% done? Sure, we have the data in our data lake, and we are going to move, now we have the ability to push the data into your ERP system so that the ERP system understands where you are exactly with the data. We have an alarm and alert mechanism on the actionable data that if we see a particular parameter is trending to cross your limits, CPK limits or your any other types of limits you have, we warn you ahead of time that, hey, the way it is trending, you're going to hit an alarm in 2 minutes or 5 minutes or 50 minutes. Go do something about it. As a matter of fact, at one of the sites I was working on, when setting it up, we saw a system fan was, a particular fan was vibrating at a level that is beyond the toleration. And then I send them a mail like, hey, is it a bad data? And am I reading it right? Or what's going on? They say, yep, I need to do something about it. Send a guy to clean the fan up, and things were fine. So you can do a lot on the other side once the data is structured, usable, actionable. Okay, let's see. How are we doing with time? Good. So we have a few more minutes, and then we'll go into Q&A. So that's the beauty. And one thing we feel very proud about is that we have hidden all the complexity of the data lake from you. We manage that. We have figured out how to do the connectivity between them, like you have 4 types of actionable data, 1 type of raw data, you have a processing engine in between dealing with it. All these things are hidden from you so that you don't have to worry about it. One thing we have observed, especially with the mid-sized manufacturers, is their IT team is generally pretty small. I mean, they don't have a huge IT team who will go and figure all these things out and make it work and all those things. We have done or dealt that complexity for you. It is in the cloud. You don't have to deal with any of that. Make sense? Okay. So I think that's about a lot I have. So our goal, of course, is, once you collect and connect to your environment, you put the data into the data lake, you process the data, you have that actionable insights. That now allows you to start acting on it and start, improving. So that's why we call it a continuous improvement cycle. And if we can go to the next slide, this is my favorite slide, that once you're on it, you start seeing things getting better and better over a period of time. Quite often we go to customers and prospects, they have literally no insights, and as soon as they start seeing some, alarm alerts, job progress, machines data, they get excited. Like that's good. Now I can see from my, evening, the store the shop floor manager, like in the evening over my dinner, that how is my machines performing. That itself gives them a lot. But then once you go past that, I still call it a reactive insights, means it already happened, it's in the past, you are seeing it now. Then you go into a little bit proactive insights that we start warning them a little before it happened. And then the holy grail, of course, is the predictive insight, where you kind of get to see it a week before something happens, right? Because one of our customers say that, look, my chiller system, it is an injection molding company, when it goes down unannounced, my productivity is gone. I lose like 7 days because I have no way to get a people come in to fix it. So if you can predict it 1 week ahead of time, that will save me thousands, if not 100,000 worth of money. So that's what our goal, and we believe that the path to it is getting all the data into the data lake, process it, enhance it, do the correlation in the data lake itself, and make it useful, not only by your analytics engine, by also making it available to the other applications that you may want to build on top of the data. Make sense? Cool. Okay, that's all I have. I think we have a little bit of time for Q&A. We have extra mics, or how are we doing it? Oh, there it is.
Thanks, Katie. That was great. Questions for Katie? Come on, he didn't answer all your questions. Somebody's got a question. There we go.
Katie thinks that was really good. Other presenters have used the phrase unified namespace. Is that the same as a data warehouse?
You know what? I'm having a little difficulty.
Some other presenters have used the term unified namespace. Is that the same as the data warehouse?
Data lake, first of all.
Yeah.
No, so the unified namespace is more about standardizing some of the attributes. Okay, so when you are saying it's job, what is it? What defines a job? It has a job number, it has a item number, and those kind of things. So data lake is more about collecting all the data in one place and unstructured data, everything, and then acting on that. Okay, so for example, one of my customers, they literally called me a few days back and said, "Hey, Katie, can you build this report? Do you have this data in the data lake? We didn't think we will need this report in the past, but now we do." It was in the data lake. We built it for them, and they are impressed because in their JDE database, that data is a transient data. They scan it, and it goes away. But in the data lake, since you have all the history, we could do it without any problem. So it's a little different, and but the main idea, keep everything in the lake so that it's available for you for processing, if that makes sense.
So when you're going through the process of enriching the data, when you're getting it into the system, you're starting with very basic kind of JSON data, you're trying to clean it up. All of that, the additional attributes, are you pulling those directly from the machine, so you're kind of making some relationship going, I know it's from whatever manufacturing, and so we're just kind of attaching this string to it, or are you building in an understanding of other systems as well?
We are definitely building understanding from other systems as well. Okay, and how do I do that, right? So the way it works, again, that's one of the beauty of data lake, right? So let me think about an example here. You got a sensor data coming in, the example I was giving, which has no idea about what job is running, what product is running, correct? All it knew, this temperature sensor sends 273 at this point of time, nothing else. But we, because we are the data lake, where I have data from other systems, I know from the MES system, for example, what job is running at that point, what product is running, possibly from the ERP system, right? And then I can collect and connect the data and enhance it in the raw data, and one of the examples I had on the screen, to add those things. So our understanding comes from the fact that we have data from multiple systems, and we can attach the data, make the data more trackable, traceable, and all those things. Makes it pretty unique.
We have a question over here.
Hi, how do you keep the size of the data lake manageable? It sounds like these could get very large.
Say one more time.
How do you keep the size of the data lake manageable?
The size of the data lake manageable? That's a good question. As a matter of fact, at one of our customers, our data lake already has more than 1 billion records already. There are two answers I'm going to give. The technology stack we picked, or if you are picking your own, I would encourage, go for something that can deal with billions of records, literally. So that's one part of it. That's where SQL just failed for us. I mean, as soon as the sensor data went above 1 million or so, it just became unmanageable. Beyond that, you do two other things. One, remember I talked about downsampling, right? So, for the first week, you are keeping data every second. But then, data beyond a week, you can do some calculations like average, or depending on, you may decide to keep the max value for that particular minute, and you downsample it to a minute. Over a quarter, You may downsample it to an hour and keep it because you do not need that granular data beyond a quarter, maybe, right? And it depends on your business, depends on your what machines you run, etc. And then, of course, the last part of this is backup and recovery, right? So most customers will say, hey, I don't care about data more than 2 years. So as long as you have data for 2, I'm all good. And at that point, you archive the data, move it out of the data lake.
Terrific. Thanks, Katie. That was a great presentation.